Hello everyone, in this video I'm going to be teaching you guys how you can solve for the surface area using parametric equations. We have the parametric equations x is equal to t plus e to the power of t and y is equal to e to the power of negative t while t is between 0 and 1. But before I get into that, you guys need to know that the formula for the surface area is equal to 2 pi times the integral from b to a. So like for our parametric equations, our intervals would be from 0 to 1. And then y times ds. But I'd like to explain to you guys why this is the formula for the surface area. So if we just have like a random curve, then to find for the surface area, we're going to rotate it about the x-axis. And if we do that, it'll look something like this. And let's say here is A, and here is B. Then we're going to we're going to make a line, and okay, well, this is kind of curvy, but it's supposed to be like straight. And so this length here would be dx, and this length here is dy. I'm not sure if you can see that correctly, but this length is dx and this length is dy. And that means that this length would be equal to the square root of dx squared plus dy squared. And we just used the Pythagorean theorem. And we're just going to say that this is equal to ds. And so it's like this is kind of like a rubber band, and so like this is kind of like this. Except it's a lot longer. So it's like this. And if we cut this part, then we'll just have a long strip of like rubber band. And we know that this length is ds, and the length from top to bottom, so this length is y. And since the radius is y, so like this radius is y, that means that if we cut it and flatten it out, then the circumference, this length would be 2 pi y, since the radius is y. And so we multiplied 2 pi y with ds from our interval to find for the surface area. This is the formula for our surface area. Now I'm going to erase it, okay? Okay, now that we know why this is the formula for our surface area, we're going to put what we know into the y and the ds. We'll have 2 times pi times the integral from b is 1 and 0 is a. Wait, hold on, sorry. Integral from 1 to 0 of y, which is equal to e to the power of negative t, of ds, which is the square root of dx squared plus dy squared. But since we want it in terms of x, we're going to divide dt, so that we would have dx divided by dt squared plus dy divided by dt squared. And so we'll have this multiplied by square root of dx divided by dt is equal to just this derivative, which is 1 plus e to the power of t squared plus the derivative of y, which would be negative e to the power of negative t squared. And we're going to add dt since we're going to be integraling this in terms of t. And now we're going to try to simplify what's inside the square root. So it would be equal to 2 pi times the integral from 0 to 1 of e to the power of negative t times the square root of, well, 1 plus t to the power of, e to the power of t is, in that squared is equal to 1 plus 2 times e to the power of t plus e to the power of 2 times t plus the squared of negative e to the power of negative t is equal to e to the power of negative 2 times t. Now, as you can see, we can't really simplify anything else, right? And I don't think that you can just integral this by hand, and that's why we're going to use a calculator to do so. And if we integral this, we'll have to do it approximately, right? And if we integral this approximately, then we'll have, okay, so if we integral it approximately, then we'll have 10, okay, well, we'll have 10.6705. So I guess you can leave the answer like this, but if you wanted to do it with a decimal, then you can do it with a calculator and you'll get this. Thank you for watching, everyone. So in this video, I explained to you guys how the formula of the surface area is this. And I also explained it to you guys how to find for the surface area for the parametric equations x is equal to t plus e to the power of t and y is equal to e to the power of negative t when t is between 0 and 1. Thank you for watching, everyone. Have a great day.